Ladies and gentlemen, greetings from Hungary. My name is Marta Alexi, and I'm working at the Faculty of Informatics at Lorand University, Budapest. I'm working at the Faculty of Informatics, but my basic profession is agricultural engineer, and I've got my PhD in animal science. Since 2016, we've been working together with my IT expert colleagues in our agri-food or precision farming research group at our faculty. We have several very interesting pilot projects in precision farming, and one of it is the tracing of mangalica breeding stock in outdoor system. I would like to introduce to you some interim research results of this pilot project. About the topic, in addition to large-scale, intensive, conventional pig housing systems, there are farm technologies in which under free or semi-free conditions with extensive feeding, with or without minimal automation, extensive or intensive pig breeds are kept, bred, and fattened. The collection of individual digital data is also becoming increasingly important in these organic pig farming systems as well. By transforming the data into information, the farmer's decisions could become more accurate and predictable. Customer confidence in this type of premium quality products can be strengthened, and the concept from farm to fork can be established right from the first step of the production. Our aims of our projects is we have some direct aims. I would like to talk now about the direct aims. For example, how can we collect individual digital data on the behavior of mangalica breeding sows kept on pasture? Or does the weather have any effect on the activity of mangalica sows? Or do we find repetitive or frequent patterns of behavior in the social web of sows? You see. Or research infrastructure. We're using 25 blonde mangalica breeding sows, and these animals are individually marked with air tags containing passive RFID, numbered from 1 to 25 because the RFID identification number is too long for the daily using. And we put this RFID in both ears of the sows. So it means A and B. So it means that one sow with 1 AB and the second sow is with 2 AB and so on. The sows are kept outdoors all year round in group housing system. And this system is characterized by extensive feeding and husbandry system. We installed 4 reading units, which are located around the wallowing site and record the presence of the marked sows. And the readers record temperature, barometric pressure, and relative humidity values on an hourly basis. Some results about the social behavior, first of all. On the left side, you found these bubbles, and the bubbles we're using, by the way, we're using business intelligence models to visualize our results. So the bubbles appear to show the individual activity of sows. The larger the bubble, it means that the more time the sows spend in the study space. And when we took the first most active sows, we found that the 5 most active sows arrived together and spend almost the same time in the observation zone. And we found that the second most active 5 sows also moving together, but just after the first sows, the first group of sows with 2-3 hours. And an effect of the weather condition on activity of sows, we found a very interesting thing that you can find on the left side on the top, that the wallowing area was most often visited by sows between 0 and 4 degrees, so not in the hot weather, but we supposed before. And when we examining the 3 seasons results, because we started our experiment in 2020 in July, and still going on, and now we have 3 seasons results, one from summer, one other from autumn and winter, and you can see these 3 charts. The first is the summertime that you can find on the right side on the top. And there are these 2 peaks visible, and it's absolutely normal. And if you find that in every season, you find the first peak, it's around the morning, it's around 7 p.m., but it's not because of the feeding time of the sows by the farmer, it's because of the natural behavior of the sows. So that was the baking time of the sows in the morning. And when we see the second peak, we find that, for example, in the summertime, the second peak's distance is bigger from the first peak than, for example, in the winter time, that you can see on the right side on the bottom. And it's because of the length of the daytime. So because the time is up, and I would have liked to show you just the most interesting results of our experiment. So thank you very much for your attention.